Okay, continuing on. Next up, find the Cartesian coordinates for the circle in the following problem. Sketch the graph in both the coordinate system and the polar coordinates. Well, polar coordinates as it is, we know this is a circle wrapped around the y-axis with a diameter of, and this is about 1.7, so 3, this is about 5, so that's 2, 4, 6. So you go up 1, 2, 4, 5 point some, and that's the diameter, because that matches r equal a sine of theta like we mentioned. Now if you want to find the Cartesian coordinates, we know how to do that. We would multiply by r both sides. We'll get r squared to equal 3 radical 3 r sine of theta. So this is x squared plus y squared equals 3 radical 3y. X squared plus y squared minus 3 radical 3y plus a number equal, take half of the middle number. So take half of 3 radical 3, which is 3 radical 3 over 2, and square it. You will get a 9 times 3 over 4, 27 over 4. And this becomes x squared plus y minus the number before you squared it, and that's 27 over 4. So here we have a circle with a center of 0, 3 radical 3 over 2. Remember, we said this was 3 radical 3, so we're going to go halfway through. And the radius is going to be 27 divided by 4 square root, which is 3 radical 3 over 2. So we move 3 radical 3 up, 3 radical 3 down, to the right, to the left. We connect the graph, and there it is. If you'd like to sketch this in two separate graphs, you can. Here, again, we already aware what this look like. This is r equal a, the cosine of theta. So if this is 2, 4, 6, this is a circle wrapped around the negative x-axis with a diameter of 3, something like this. I could use the technology to sketch a graph, but I want to just, oops, how did that happen? I just want to make sure that this is equivalent to what you're going to do on a test. I provide the grid, you give me the graph. And to convert, you multiply by r both sides. R squared equal negative 6r cosine of theta. X squared plus y squared equal negative 6y. 6x, I'm sorry. R cosine of theta is x. X squared plus 6x plus a number plus y squared. Take half of the middle number, which is 3, and square it. So we have a circle with a center of negative 3, 0. Remember, these were 2, so negative 3, 0. And the radius is 3. So you move 3 to the right, 3 to the left, 3 up, and 3 down, and you can make that with a circle, and there it is. Again, if you'd like to make this on a separate graph, you can. How about here? That runs all the way through 32. Now here, oh, I don't think I got the directions. Let me get them. Here we're dealing the other way. Here we go. Directions. Find the polar coordinates of this. Sketch a graph. Now on your test, I might give you two different grids, one with those circular and one with the rectangular, but or just one. It doesn't matter. So I look at this. I say, okay, well, let's see what this is. This is in rectangular coordinates. First things first, right? This is x squared plus y squared minus 2y plus half of the middle number is 1 and square it. X squared plus y minus 1 squared equal 1. So we have a circle with a center of 0, 1 and a radius of 1, 0, 1. We go up 1, down 1, 1 to the right, and 1 to the left. And if I was to find the polar equation of this, then I would say r squared minus twice r the sine of theta equals 0. Factor an r out. and r equals 0 is just a point. R equal twice the sine of theta. This is a circle wrapped around the positive y-axis with a diameter of 2, and there it is. So idea is fairly simple. Same with this. If I'm to look at this, say, okay, well, if I want to graph this, well, I could find the polar first. I could say this is r squared plus 4r cosine of theta equals 0. Factor in r out. So r equals 0, that's just a point, and r equal negative 4 the cosine of theta. Well, I know how this works. This is a circle wrapped around the negative, and let's say that's 2, with a diameter of 2. If I want to find the center using rectangular coordinates, I'll say this is x squared plus 4x. Take half of the middle number, which is 2, and square it. So this becomes x plus 2 squared plus y squared equal 4. Center is negative 2, 0, and the radius is 2. So negative, right. When I did this 4, I didn't label. So negative 2, 0 is right there. Move 2 to the left, 2 to the right, 2 up, and 2 down, and connect them with a smooth curve. There it is. Alright, and here, really it doesn't matter whether r is positive or negative. If you say r is, so I know that this is, if this is 2, this is 4, this is a circle wrapped around the negative y-axis. And the fact that r is between 0 and that, even if it was positive, since you're going to trace all the thetas, well, think about it this way. Theta equal pi over 4, r is negative, you're going to be pointing this, 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 and you're going to get all of these points, and eventually you're going to trace all of that graph. So fairly simple. Find the area enclosed by one leaf. Alright, well, let's see how this works. It's, I forgot. I need to center this so I can see it better. So all what I have to do is go up 1. And again, I suggest strongly that you sketch a graph of one of these fully from scratch, meaning trace the graph from this to this. Here we're going to use our knowledge by now. This is 2 pi over 3. This is half of that pi over 3. This is half of that pi over 6. So I need the pi over 6's. Let me put those on the grid. So let's say that's 30 degrees. Another 30. Another 30. And another 30. So at 0, I am at 0. By the increases, by the time I reach pi over 6, I am at 1. I should have eliminated those. I forgot about that. Oh, not that one here. Oh, come on. There we go. So, increases. By the time I reach pi over 6, there's pi over 6. I am at r equal 1. Pretty much I'm done. This is a 3-leaf graph. So they're 2 pi over 3 apart. 2 pi over 3 over 6, that's 4 pi over 6. So if this peaks right here, 1 pi over 6, another 4, it's going to happen. 1, 2, 3, 4. So if I am at 1 and I went 4, that's 5 pi over 6. And another 4. 1, 2, 3, 4. That's the whole graph. Now, if I look at the area, it says, find the area equal the integral of the polar, they only want one leaf. Well, if I run from 0, you notice that to pi over 3, I've traced all of this. 0 to pi over 3 will do the trick. 1/2 r squared d theta. And r squared is the sine of 3 theta. And for those of you that have been asking me to work this out in class, Well, that's okay. You could always review a bit more, not a problem. You should know how to do this. This is using power reduction. That's 1/2 the integral. And this is 1 minus the cosine of 2 times that. And that would be 1/4 if I take this 2 out, of what? Theta minus the sine of 6 theta divided by 6 evaluated from 0 to pi over 3. That is 1/4. If you put pi over 3 in there, you get that. If you put pi over 3 in there, 6 times that is 2 pi. Sine of 2 pi is 0. When you put 0, you get 0. So this is pi over 12. That's the area of this one leaf. And of course, if you want all of them, just multiply that by 3. And if I look at the next problem, and that's the last example we have in the review, but again, in the homework, you notice we did way more than this. This is just a quick refresher. Let me center this really quickly. Here we are. So if I would go ahead, I want to look at, let's see, this here. Let me color code those. Let's go with the red. This is a circle wrapped around the positive y-axis. With a diameter of 2. There. And this is if I go up 2 units, I am at r equal to, I'm going to go 2 units above and 2 units below. So I'll be at r equal 4 and r equal 0. Graph of a sine wave starts at the origin. This is 2 pi, this is pi, this is pi over 2. So we know this is going to look something like this. At 0, I am at 2. At 0, there's 0, 1, 2, I'm right there. Increases. By the time I reach pi over 2, I am at 4. There's pi over 2, and there's 1, 2, 3, 4. And then decreases back. By the time I reach pi, I am at 2. There's pi, and there's 2. And then keeps on decreasing. By the time I reach 3 pi over 2, I am at 0. There's 3 pi over 2, and there is 0. Well, that's odd. Those don't even intersect. Okay, and what does it want? Find the area inside of the bigger, outside of the smaller. Inside of the bigger, so inside of the green, outside of the red. Okay. Here we are. How does that work? Well, area is going to be the integral. Now, if I run this from 0, then that's going to run the tip will be the green, 1/2 the green squared d theta, the green minus, and the inner will be the red. And it's all d theta. So how does that work? The green is simply 2 plus twice the sine of theta, so that's the tip of the arrow. The base is the red, and the red we already said that was twice the sine of theta. Oh boy. And if I run this from 0, running all the way to pi over 2, that'll do 2 times. But that's going to find this part. I still have to find this part. So do you see here, if I run, and again, there are so many different ways you could do that. You could say go from pi to 3 pi over 2. You could go from negative pi over 2 to 0. But if I go from plus the integral, I'm going to say from pi to 3 pi over 2, and there's 2 of those. And I could say 1/2. And here, do you see that there's no red, it's only green. So the green is pretty much 2 plus twice the sine of theta. You can't do this with a single integral. It has to be both integrals. And that pretty much concludes the second review of this chapter, which is the polar coordinates.